Hello friends, welcome to Independent Learning. My name is Raj Shah, and in this video we are going to continue with the chapter triangles. Okay. In the previous video we saw we took two triangles and we saw how to prove that two triangles are congruent. We saw various tests, okay, to prove that two triangles are congruent. In this video we are continuing with the chapter and we are starting with the topic. We'll be looking at some theorems, which is Isosceles Triangle Theorem, 30-60-90 degree triangle theorem, and 45-45-90 degree triangle theorem, and also the last one, which is median of a triangle. Okay, theorem based on median. Okay, so let's start them one by one. So the first one, which says if two sides of a triangle are congruent, then the angles opposite to them are congruent. Okay, so this says that if two sides, so there is a triangle. First of all, let me tell you what is an isosceles triangle. So isosceles triangle says that if the two sides of the triangle are congruent, then the angles are also congruent, which is this angle and this angle. Or if the two angles, these two, see this and this angle, if they are congruent, then these two sides are also congruent. Okay, so that's the theorem. Okay, so we are going to prove that in the form of theorems. The first one, which says if two sides of a triangle, so two sides here AB and AC, we are considering that they are congruent. Okay, then the angles opposite to them, so this side ke opposite angle is this and this side ke opposite angle is C. So opposite angles, okay, they are congruent, we have to prove. So sides are congruent, but angles is to be proved that they are congruent. Here this theorem says this, but here this is the converse of this, which says that if angles are congruent, then the opposite sides, okay, so for this angle this is the opposite side, for this angle this is the opposite side. So if the angles are congruent, see, then the opposite sides of them are congruent. So this is the theorem and this is its converse. So we'll just write here, okay, converse, which is ulta, we have to prove. Okay, so let's start with the proof here. So what is given to us? Okay, in triangle ABC, okay, in triangle ABC, AB is congruent to AC. Okay, now what is to be proved? Nothing else is given, correct? What is to be proved? Angle B. So we can say to prove, okay, angle B, or we can write it in terms of angle. We can write this as angle B and angle C, or we can write it as ABC, okay, congruent to angle ACB, correct? So you have to prove that these two angles are congruent. Okay, now why am I not writing just angle B and angle C? Because I'll have to do a construction and the name may change. That's why we are taking a 3-letter naming. Okay, so let's see. So this is to be proved. Now we'll do a construction for this, which passes through from A, passing through BC at point P. Okay, so we have done a construction here. We can write that. So construction says draw, or you can say, okay, draw ray AP on, draw ray AP passing through BC, correct? So here we have done this construction. Now let's see the proof. Okay, so first of all, okay, these two angles we have to prove. So you already know, okay, you already know that if the two triangles, okay, if we are able to prove that the two triangles are congruent, okay, this triangle and this, if we are able to prove, then we can easily prove that the two angles are also congruent. Why? Because congruent angles, corresponding angles of congruent triangles, yes or no? So that's why. So what we'll do, how will we approach with the proof? We'll prove that the two triangles are congruent. So let's consider these two triangles. So in triangle ABP and triangle ACP, okay, ABP and ACP, so we're considering these two triangles. Then what is given here, AB and AC, they are congruent, so we write that AB is congruent to AC. Why? So reason for this, reason for each and every statement is to be written always, okay. So this reason for this is that it is given, okay. Then let's see what else. This is to be proved, so we won't consider this. Now AP and AP, or you can take this, okay, this and this, because we have drawn an angle bisector. Okay, I have not mentioned here. Draw angle bisector on A. Okay, draw angle bisector on A passing through BC. Okay, and meeting at point P. So you can write that. So if we are drawing angle bisector, that means these two, okay, these two angles are congruent, which is this and this. Therefore we'll say angle BAP and angle CAP. Correct? So these two angles are congruent. Why? Construction. Okay, so we can write that. Now AP and AP, they both are same, they both are there. See, AP and AP, they both are there in both the triangles. I mean AP is there in both the triangles. Therefore we'll say AP is congruent to AP, because if you consider ABP triangle, okay, ABP, AP is the side, and if you consider ACP as the triangle, okay, there is AP as the side also, the third side. So we can say that AP and AP, they both are same, therefore reason will be common side. Okay, now if what have we proved? SAS. So by SAS test we can say that these two triangles are congruent. Therefore triangle ABP is congruent to triangle ACP. Okay, these two triangles are congruent by SAS test. Okay, so if we are able to prove that these two triangles are congruent, from ABP we can say angle ABP is congruent to angle ACP. Why? Because the triangles are already congruent, therefore angles can also be congruent. What will be the reason? CACP, corresponding angles of congruent triangles. Okay, so I hope you have understood this. Okay, so we took two sides and we proved that the angles are also congruent, and in the opposite angles are congruent. Now we'll take the converse of this and we'll try to prove, okay, which says that if two angles of a triangle are congruent, so here what we are taking is this. Okay, these two angles are given as congruent and we have to prove that these two sides are congruent. So let's see how we do. So what is given here, in triangle ABC, so these proofs are pretty easy. Just prove that the two triangles are congruent in this as well as in this, which we'll be doing now. We just need to prove that the triangles are congruent. If these two triangles are congruent, we are able to prove, then by CACT or CSCT, we can prove that the sides are also congruent. Yes or no? So same way we'll be doing for this also. Let's keep the figure this itself. Okay, let's see. So in triangle ABC, what is given? ABP. So ABP. Okay. Okay, first of all, ABP here, right? But here we can write this as ABC is congruent to angle ACB. Why? ABP or ABC, it is the same angle, yeah? Correct? So if they are the same angle but different name, so you can write the reason here. Same for this also. ACP is written as ACB. So same angle but different name. So you can write the reason for that. Same angle, different name. Okay, same angle, different name. Okay, so I hope you have understood. Now let's get back to this. ABP, or you can say ABC is congruent to ACP. It means the same. So ABP is congruent to ACP. Correct? So this is given to us. What is to be proved? To prove, okay, AB is congruent to AC. Okay, so let's see the proof. Okay, first of all, we'll do the construction here. Same way. Okay, so the construction here will be the same. Here what we have done. Draw angle bisector, okay, on A passing through BC. Okay, so same reason, passing through segment BC and meeting at point P. Okay, we can write that, meeting at P. Okay, so that's the construction we are doing. Now let's start the proof. Okay, so again we'll take these two triangles and we'll try to prove that they are congruent. Okay, so in triangle ABP and triangle ACP. Okay, so what can we say for this now? This, okay, angle, okay, angle ABP is congruent to angle ACP. Yes or no? Because this is given to us, and this is an angle bisector. So same way like how we used here, we'll say BAP is congruent to angle CAP. Correct? Two angles congruent. Then we can say AP and AP, they both are same because common side. So we'll say AP congruent to AP because common side. Okay, so what we have got? ASA. Therefore triangle ABP is congruent to triangle ACP. Okay, why? By ASA test. Okay, so if we are able to prove that these two triangles are congruent, then this and this side will also be congruent. Therefore AB is congruent to AC. Okay, this is segment AB congruent to segment AC. You can write that segment AP, segment AP. Okay, everywhere, wherever you come across. Okay, so we have got this same, congruent by, what is the reason for this? CSCT, corresponding sides of congruent triangles. Okay, so I hope you have understood isosceles triangle theorem and its converse. Okay, now we'll take 30, 60, 90 degree triangle theorem. Okay, let's see how it's done. Okay, so before starting with 30, 60, 90 degree triangle theorem, 30, Okay, before starting with this, I want to tell you what is corollary of isosceles triangle theorem. Okay, in isosceles triangle, we discussed that if two sides are congruent, then the angles are also congruent. I mean, the opposite angles are also congruent. Okay, and if the angles are congruent, then the opposite sides are congruent. But okay, if two sides are congruent, then the two angles are congruent, the two opposite angles. What if three sides are congruent? So if three sides are congruent, okay, like if there is this triangle ABC, if AB, BC and AC, all three sides are congruent, then angle A, angle B and angle C are also congruent. Okay, so that, and converse of this, which says that if angles, okay, angle A, angle B and angle C, if they are congruent, then the opposite sides are also congruent. Okay, so if sides are congruent, if all three sides are congruent, then all the angles are also congruent. If all the angles are congruent, then all the sides are congruent. So each one and the converse. Okay, so I hope you have understood. So that was the corollary of isosceles triangle theorem. Okay, now these type of triangles we call it as equilateral triangle. Equilateral triangle. So equilateral triangles are the triangles which have same, I mean, congruent sides. All three sides are congruent, okay, and all the three angles are also congruent. So those type of triangles are called equilateral triangle. Okay, so now that was the corollary. Now we'll start with 30, 60, 90 degree triangle. Okay, so this theorem, it states that if the acute angles of a right angled triangle, so first of all let's have a right angled triangle B, A and C. So it is right angled at B. Okay, so we can say, okay, in triangle ABC, it is said that if the acute angles of a right angled triangle, angle B is 90 degree, because the triangle is right angled at B. So angle B is 90 degree, have measures 30 degree and 60 degree. So other angles, let's keep them as 60 and 30, because that's what it is. That's what the statement says, that if acute angles of a right angle triangle have measures 30 degree and 60 degree, so these two are the acute angles, yes or no? So let's keep one of them as 30 and the other one as 60. So 30, 60 plus 90 gives you 180. So sum of the angles of a triangle is 180. So this assumption we are doing, which is correct. Okay, so here I'll just write angle A is 60 and angle C is 30. Okay, so here, then, so this is given, then what are we supposed to prove? Then the length of the opposite side to 30 degree. So this is 30 degree. Which length is opposite to 30 degree? So if you see, then the length of the side opposite to 30 degree. So side opposite to 30 degree angle will be this angle, yes or no? Because this is 30 degree and the side opposite to this, it will be AB, because this and this, they are close to it and the opposite side is AB. So we'll say then the length of the side opposite to 30 degree, that is AB, okay, this side opposite to 30 degree is AB, is half the length of the hypotenuse. Hypotenuse, you know, it is AC, and you already know that if this is 90 degree, then the side opposite to 90 degree is hypotenuse. So AC is the hypotenuse. Okay, so we'll say, so it's said that then the length of the side opposite to 30 degree, which is AB, is half the length of the hypotenuse. So half of AC. So AB equal to half of AC we have to prove. Okay, to prove, so we need to understand the statement first. Okay, then we'll go for the proof. So it says that AB is half of AC, need to prove. Okay, and side opposite to 60 degree. So this is 60 degree, opposite to 60 degree, which side it is? BC. So BC is, it is root 3 by 2 of the length of the hypotenuse. So root 3 by 2 of the hypotenuse, which is AC. Correct? So this is what we need to prove. Okay, so I hope you have understood the statement itself. Okay, now let's start with the proof. So here what we'll be doing is, we'll be doing a construction, okay, such that okay, so this is what we have constructed. Let's keep this as D. Okay, so we'll write there for construction, extend AB, okay, extend AB, extend AB, okay, till D, okay, extend AB till D such that AB is equal to BD. So we are constructing this another triangle such a way that this BD and AB, they are same, and also join BD and C. So also join D and C. Okay, also join DC. So that's the construction we have done. Now what we are doing, what we'll be doing this here. Okay, let's start with the proof now. Let's see how it's done. Okay, so here we'll consider these two triangles. Okay, the first step will be considering these two triangles, proving them to be congruent. Okay, so if we are able to prove that these two triangles are congruent, then we can say that this angle and this angle A, which is BAC, and BDC, they are also congruent. So this will become 60 degree. Okay, I hope you are getting. If you're not, then let's do the proof here. Okay, let's see how it's done. So let's take two triangles, ABC and DBC. So in triangle ABC and triangle DBC, okay, so considering these two triangles, now to prove that these two triangles are congruent, let's see how we do it. Now the construction which says AB is congruent to BD, so let's take AB congruent to BD. Why? Construction. So we'll say reason, construction. Correct. Now let's see what else. So here BC, correct, BC is congruent to BC. Why? Because this is the common side. In triangle ABC, BC is there, and in triangle DBC also there is side BC. So they both are common. Therefore BC is congruent to BC. The reason, common side, yes or no? Now can we say this is 90? Can we not say this is also 90? Why? Because we had just extended this, right? Yes or no? So if we extend this whole angle will become 180, but this part, okay, this part is 90, then this part will also become 90 degree. Yes or no? It's like this. Okay, like this. If this is 90, okay, and the bilinear pair, okay, you know what is angles in linear pair? The sum of the angles is 180. So if this is 90, so this will become 180 minus 90, which is again 90. Therefore this angle and this angle, they both will be congruent. So we can say angle ABC is congruent to angle DBC. What can be the reason for this? Because each of them are 90. So each 90 degree. Okay, so here this is what it is. Now S, A and S, therefore triangle ABC is congruent to triangle DBC by SAS test. Okay, so we have proved that these two triangles are congruent. Therefore, we can say that BAC, okay, BAC is congruent to BDC. Yes or no? Which is this, okay, this and this angle. Okay, so if BAC, okay, BAC is 60 degree, then won't BDC will also be 60 degree? Therefore, we'll say if angle, if angle BAC is 60 degree, okay, BAC is 60, then angle BDC is also 60 degree. Okay, so what we have got in this triangle, in triangle BDC, so we'll say in triangle BDC, okay, angle this, so angle BBC is 90 degree and angle BDC is 60 degree. Therefore, if this is 60, this is 90, what will this angle be? 30, because 90 plus 60 gives you 150 and sum of the angles is 180. Therefore, 180 minus 150 gives you 30. So this angle will be 30 degree. So we can say BCD is equal to 30 degree. Okay, sorry. Now, if BCD is 30 degree, can we say ACD, okay, angle ACD is equal to, which is AC and D. So that will be 30 plus 30, because this also we have got as 30. This is already 60, we have proved, correct? So what will ACD be? 30 plus 30, which is 60. Therefore, this is 60. Okay. Now, if you see, angle this is 60, this is 60, and this has also become 60. So we can say, therefore, angle, okay, angle A, which is DAC is 60 degree. Okay, see, instead of BAC, we can also write DAC, correct? So DAC is 60 degree. Okay, consider in triangle ADC. So we have considered this full triangle, okay, not separately, we have considered it together. So DAC is 60, ADC is also 60, and just now we proved ACD is 60 degree. So if these three, okay, 1, 2 and 3, these three angles are 60 degree each, then this becomes equilateral triangle, okay, we just discussed. Therefore, triangle ADC is an equilateral triangle. So if a triangle is an equilateral triangle, then the sides are also congruent. So we can say, therefore, AC is congruent to AD and that is congruent to DC. Yes or no? If a triangle is an equilateral triangle, then the sides are congruent. So AC is congruent to AD is congruent to CD or DC as written. Okay. Now, from this, what we had constructed, this was our initial triangle. So can we say AB is half of AD? Yes or no? AB, which is this length, is half of AD. Why? Because this was our construction. We had extended BD such that AB is congruent. AB congruent to BD we had constructed. See, construction we have written. Therefore, we can say that AB is half of AD. Yes or no? Like, for this we can say AD be between this. Or you can write this like this also. We can say that AB plus BD is equal to AD, because why? Betweenness. Now AB and BD, they both are same construction. Therefore, I'll write AB, and instead of BD, okay, I'll write AD. AB equal to AD. Therefore, 2AB is equal to AD. Therefore, AB is equal to half of AD. So AB is equal to half of AD. Yes or no? But if you see, AD is same as AC. Yes or no? So I can say this as half AD is same as AC. Therefore, AD is half of AC. So here, first condition is being proved, which says that AB is equal to half of AC. Okay. So I hope you have understood. What does this say? The side opposite to 30 degree is half of the hypotenuse. So half of AC, which is the hypotenuse. Now let's see the second case, which says that we have to prove that this is equal to root 3 by 2 AC. So let's see how we do. Now you very well know how to use the Pythagoras theorem for this ABC. So in triangle ABC, okay, angle ABC is 90 degrees. So we are just considering A, B and C, this triangle. Okay, so considering this triangle, ABC is 90. Therefore, we can say hypotenuse square, which is AC square, is equal to one side square, which is AB square plus BC square. Yes or no? Now, so we have got this using Pythagoras. So we'll just write this, the reason, Pythagoras theorem. Okay. So after getting this, let's see. Now AB is what? Half of AC. So what we can say here, AC, so AC square is equal to, AB is what? Half of AC. So just substitute half AC and square plus BC square. Now we want BC here, right? So let's take BC on one side and this on the other side. So this will become AC square upon minus half AC square equal to BC square. Okay, I've taken this on the left hand side, so it becomes minus. Now I'll open this up. Okay, I'll do it here now. So after this, make sure that you keep on writing with me because you might get lost. Okay, so AC square minus 1 by 2 ka square is 1 by 4, and this will become AC square equal to BC square. Now I can write this as BC square. So like the pen is kept here and can be kept like this also. So switching the equation, okay, so this will become, so this will be, now you know how to subtract this. It is like 1 AC square minus 1 by 4 AC square. So that will give us 3 by 4 AC square, right? So when you take square root on both the sides, you get BC equal to root 3 by 2 AC. Okay, this is AC. So the reason for this will be taking square root. Okay, so I hope you have understood this theorem. So we proved that the side opposite to 30 degree, so this side is half of the hypotenuse. So AB is equal to half of AC, the first one here, and the second one which says side opposite to 60 degree, which is BC. Okay, BC is root 3 by 2 the hypotenuse, so root 3 by 2 of AC. Okay, so I hope you have understood this. Now we'll take the next theorem, which is 45 45 90 degree triangle. So here we are doing 45 45 90 degree triangle theorem. Okay, so this theorem which says that if measures of angles of a triangle are 45 45 90 degree, so 45 45 and 90 degree, okay, of a triangle, then the length of each side, okay, first let's write what is given. So what is given here is, okay, in triangle ABC, okay, angle B is 90 degree and angle A congruent to angle C, they both are congruent and their values are both equal to 45 degree, correct? Now what is to be proved? Let's see. So to prove that length of each side, so length of each side containing the right angle, so this is the right angle and the side containing right angle is AB and BC. So AB and BC, they both are, we have to prove that containing the right angle is 1 by root 2. So this is equal to 1 by root 2 of the hypotenuse, which is AC. So the theorem says if the measures of the angles are 45 45 90, then the length of each side, so length of each side containing the right angle, so there are two sides here containing the right angle and we have to prove that both of them are equal to 1 by root 2 of the hypotenuse. Okay, so we have to prove that this and this both are equal to AC, correct? Now if this is 45, this is 45, angle A and angle C, we can say that AB and BC, they are congruent. Why? Because isosceles triangle theorem we did. Okay, actually converts isosceles triangle theorem. So we can write this in given itself, AB congruent to BC. Okay, this can be written in given itself. Now let's see the proof. Okay, so here let's consider this triangle. In triangle ABC, angle B is 90 degree, correct? Now angle B is 90, therefore by Pythagoras theorem we can say AC square is equal to AB square plus BC square. Reason, Pythagoras okay, so by Pythagoras theorem we can say this. And now we know, okay, AB and AC, they both are equal. So can I write, instead of BC, can I write it as AB itself? So I'll write it here as AB square plus, instead of BC I'll write AB. So this will become AB square again. Yes or no? Because we can write the reason, AB is congruent to BC. So that's the reason. Okay, AC square. Now this will be equal to AB square plus AB square, that will be 2AB square. So 2AB square equal to AC square. The 2 will come down, yes or no? So therefore we'll get AB square is equal to 1 by 2, correct? So 1 by 2 of AC square. Okay, so 1 by 2 of AC square. Now what we do, AB is equal to 1 by root 2 of AC, taking square root on both the sides. So that will be the reason. Sorry. So taking square root on both the sides, we can get AB is equal to square root of 1 is 1, square root of 2 is root 2. So 1 by root 2 of AC square ka root is AC. Yes or no? Because you know, if you write 3 square and you take square root of this 2 and square root will go and you will get 3. Yes or no? So that's why you get AB, square root of AB square is AB. Okay, so this is what we had to prove, and AB and BC, they both are same, therefore we can say AB is equal to BC is equal to 1 by root 2 of AC. So hence we have proved, okay, that side opposite to 45 degree, or the angle, sorry, the sides containing the right angle is equal to 1 by root 2 of the hypotenuse. Okay, so this is 45 45 90 degree triangle theorem. Okay, so let's take the last theorem, which says about the theorem on median. Okay, let's see what it is now. So we are doing medians. Okay, medians of a triangle. Okay, let's see the definition first. So the definition says the segment joining the vertex or and the midpoint of the side. Let's draw a triangle first. A, B and C. Okay, so a segment joining the vertex. So let's take this vertex A. So a segment from A joining the midpoint of the side opposite. So let's say this is the side. So if we are drawing this, okay, a segment joining, okay, joining the vertex and the side opposite, which is BC, at point, let's say this as P. Okay, so this is called a median. So here AP is the median. Okay, so from any vertex we can draw. Let's find the midpoint of AB. Let's say it is this point. So from this point to point C, the line okay, so the line passing through this point, which is midpoint of AB and C, vertex C, is called the other median. So there are two medians in this triangle, AP and CQ. So CQ is also a median. Okay, so there can be three medians possible from here also. Okay, so that's all about median. Now we'll take a theorem based on median. Okay, so what we are doing here is we are taking, okay, so what we are doing here in a right angled triangle. Okay, so we are taking a right angled triangle. So this is 90 degree. Okay, so in a right angled triangle, the length of the median, so let's say this is the median. Okay, this is the median. So the length of the median of the hypotenuse, so this is the hypotenuse. Yes or no? Why is this the hypotenuse? Because this is 90 degree, therefore this will be the hypotenuse. Let's name it. Okay, let's name this as A, B and C, this as D. Okay, so what it's saying here, the length of the median, so BD, okay, so you have to say BD is equal to half the length of the hypotenuse. So this is equal to half of AC we need to prove. So we need to prove that BD, which is the length of the median, is equal to half of the hypotenuse. Okay, that's what we need to prove. What is given to us? So here what is given? Angle B is, or you can say angle ABC equal to 90 degree, correct? And BD is the median. Okay, so if BD is the median on AC, then we can say that AD is congruent to CD. Why? Because D is the midpoint of AC. Because median says that you draw from a vertex to the midpoint of the opposite side. So D is the midpoint of AC. So if D is the midpoint, then AD and DC, they both are congruent. Yes or no? Therefore, this is given to us and this is to be proved, that the length of the median is equal to, so length of the median, which is BD, is equal to half the hypotenuse, so half of AC. Okay, so let's see how we do. First of all, we'll do a construction. Okay, construction which says okay, so we draw a construction such that AB, okay, let's name this as E, is we have extended BD, so extend BD, so we have extended the median till E such that BD and DE they both are same. Okay, so we have constructed this in such a way that BD and DE they both are same, so we'll just represent this, and this is already congruent because D is the midpoint of AC, yes or no? So this is already congruent, and this is by construction, and also after getting point E, join AC. So join EC. Okay, so this is the construction. Now let's see the proof. Consider these two triangles. Okay, in triangle ADB, and triangle CDE. So we have considered ADB and CDE, these two triangles. Okay, now we'll try to prove these two triangles congruent. Let's see how. So we can say AD is congruent to CD. Okay, yes or no? Why? Because that is given. Yes or no? Because D is the midpoint as it's a median. Therefore, the reason for this will be given. Yes or no? Now, BD is congruent to ED. So BD is congruent to ED. Why? Because this is construction. Okay, so construction, and we can say that these two angles are congruent. Why? Vertically opposite angle. You know what is vertically opposite angle? If there are two lines crossing each other, then the opposite angles are congruent. So these two angles are congruent and these two are congruent. So we can say, okay, angle ADB is congruent to angle CDE. Okay, the reason for this, vertically opposite angle. Okay, so this we have done in parallel lines. Okay, if you're not sure about this, go back and check the chapter on parallel lines. Okay, so what we have got, S, A and S. Therefore, triangle ADB is congruent to triangle CDE by SAS test. Correct? Therefore, we can say that ABD, correct? So angle ABD is congruent to, okay, ABD is congruent to CED. Yes or no? Because if these two triangles are congruent, this angle, they will be congruent, or this angle and this angle, they will also be congruent. Yes or no? So if you see ABD, which is this angle, and CED, which is this angle, so they are forming what? Z. Yes or no? So what are they? Alternate angle. Okay, first of all, the reason for this is CA, CD, corresponding angles of congruent triangles. Now because of this, these two angles are alternate angle, therefore we can say AB and EC. So AB is parallel to CE. Why? Because by alternate angles test, we can say that these two are parallel. So we can say Okay, alternate angles test, correct? By alternate angles test, these two are parallel. If AB and CE, okay, AB and CE, they are parallel, and also, okay, AB and EC, or you can say this alternate angles, they are congruent. Can we say that ABCE is a parallelogram, or sorry, a quadrilateral? Sorry, extend this also in construction. We forgot to mention this. Join AE also. Okay, ABCE, okay, quadrilateral ABCE is a parallelogram. Yes or no? Now you know that the condition for parallelogram, to prove that quadrilateral is a parallelogram, it is that two sides, okay, both the pairs of opposite sides are parallel, or you can say opposite sides, okay, if opposite sides and angles, they are congruent, then they are this is called a parallelogram. Yes or no? And also you can say that if the sides are parallel, if one of the side is parallel as well as congruent, okay, as well as congruent, then we can say that this is a parallelogram. So here we have proved that AB and EC, they are parallel, but also we can say that AB is congruent to EC. Yes or no? AB, here I can say AB is congruent to EC. Why? Because these two triangles are congruent, therefore this side is equal to this side. Why? The reason for this: CS, CT, corresponding sides of congruent triangles. Therefore, if one side is congruent as well as parallel, therefore this becomes a parallelogram. Yes or no? Now, if you see this, we have proved that it is a parallelogram. But if you see ABC, so one angle of a parallelogram, so it becomes like this: A, B, C, and E. So this is a parallelogram, and angle B is 90°. Therefore, if angle B is 90°, not B actually, ABC. So we can say angle ABC is 90°. Therefore, quadrilateral AB, because even one angle, if it is 90°, then the quadrilateral becomes a rectangle. So ABC is a rectangle, correct? A, B, C, E. Okay, so I hope you have understood this till here. Now, if this is a rectangle, we can say that the diagonals are congruent. Therefore, AC is equal to BE. Why? Because diagonals are congruent of a rectangle. So we can say diagonals are congruent. Okay, because these two are congruent, we can say that D is the midpoint of BE also, same like this, because we have already constructed this. Yes or no? BD is equal to D. Therefore, we can say D is the midpoint of BE also, and same way we can say that BD is equal to half of, so BD is equal to half of BE, and now BD is equal to half of BE, but BE is equal to AC. See, therefore we can say BD is equal to half of AC. Correct? So this is what we got the proof here. Okay, so I hope you have understood this. Okay, so we did theorems on isosceles triangle, 30, 60, 90 and 45, 45, 90° triangle theorem, and also on medians. Okay, so I hope you have understood this. If you have understood this video, make sure that you share it with your friends. Okay, in the next video we are going to study about perpendicular bisector theorem and angle bisector. theorem, okay, and questions based on them. Now, questions based on the theorems which we did, okay, the questions are pretty much easy for you, okay. Based on the theorem itself, we need to just can find the answers for it, okay. So I hope you will be able to solve questions based on these theorems, okay. So if you have understood, make sure that you share it with your friends, okay. Thank you for watching.